Hey guys, in this lesson we would understand how to write down the end behavior and symmetry of polynomial functions when we are given the polynomial function in the form of equations. Let's say we're given a polynomial function as fx equal to negative 3x to the power of 5 plus 4x cubed minus 8x squared plus 7x minus 5. If we need to write down its end behavior, what do we have to do is just check the degree. Degree is 5, that means it's odd degree function, and check its leading coefficient. Leading coefficient is negative 3. We just need the sign of the leading coefficient and it's negative. Now we know an odd degree function with leading coefficient or a negative would lie in the second and the fourth quadrant. So this is the most important thing to remember from the previous lesson. Therefore, using these endpoints, we can write on its end behavior. So this means second quadrant and this means fourth quadrant. Therefore, the end behavior is going to be if x approaches, because the first one is when we go towards the left side. So when x approaches negative infinity, y is on the top quadrant. So it's going to approach positive infinity. And when x approaches positive infinity, y approaches negative infinity because it's in the bottom quadrant. So whenever we need to write down the end behaviors from the given polynomial equations, we need two things. One is the leading coefficient is positive or negative, and the second thing that we need is the degree is odd or even. If we have an odd degree function with a positive, then it would lie in first and the third quadrant. If we have an odd degree function with a negative, it would lie in the second and the fourth quadrant. If we have an even degree function with a positive, it would lie in the first and the second quadrant. And if we have an even degree function with a negative, it would lie in the third and the fourth quadrant. So always remember, first quadrant would be part of both odd and even degree function when a's are positives, and fourth quadrant would be part of both odd and even degree functions when a's are negatives. Or we can just memorize this. Odd degree is third to first with a positive and second to fourth with a negative. Even degree is second to first with a positive and third to fourth with a negative. Just remembering these would help us write on the end behavior when we are given the equations. However, when we are given a general graph and looking at the graph, they ask us to define, and looking at the graph, the question asks us to write down the leading coefficient. We just have to look at the endpoint. So this is first and third. First and third means leading coefficient is going to be positive because we notice here that the endpoint lies in the first quadrant if a is positive. Because if a is negative, the graph would never lie in the first quadrant. However, the graph would definitely lie in the fourth quadrant if a is negative. Since this graph's one endpoint is in the first quadrant, therefore the leading coefficient is positive. If they ask us about whether this is going to be an odd degree or even degree function, we know it's third and first quadrant. It's going to be odd function. For odd functions, the endpoints always lie diagonally. If it's first, the other endpoint will be third. If it's second, the other endpoint will be fourth. Whereas for even functions, the endpoints would always lie adjacent to each other. Here, since the endpoints are lying diagonally opposite, so the degree is odd. And if we are asked to write on the end behavior, we can just use this information. If x approaches negative infinity, we see y approaches negative infinity. If x approaches positive infinity, y approaches positive infinity as well. Next is how to find if a given equation has an odd or an even symmetry, because from the graph we can just look at the symmetry about origin or symmetry about y-axis. What do we do if we are given an equation? Let's say we're supposed to find out the symmetry for the question. Fx is equal to x to the power 4 minus x to the power 3 minus 4x squared plus 5x. Because the degree is even, we're not going to conclude that the symmetry is even, because finding the symmetry from equation does not mean it's same as the degree of the equation. Therefore, what we have to do is, we know the value of fx when x is positive is this. Now we would find out the value of fx when x is negative. So everywhere we see x, we would sub in negative x. So this would give us negative x to the power 4 minus negative x to the power 3 minus 4 negative x to the power 2 plus 5. Here comes negative x in place of x. Now negative x to the power 4 is nothing but x to the power 4 because it's even power. Negative x to the power 3 is nothing but negative x cubed. Negative 4 because now again it's even power, so it becomes x squared. Here negative x to the no power means it's power 1, so it will be negative 5x. This gives us x to the power 4 plus x to the power 3 minus 4x squared minus 5x. Now what do we have to do is we have to compare the fx with f of negative x. And how do we compare? If all the terms of fx and f of negative x have exactly same sign and same numbers. For example, here x is to the power of 4, here x is to the power of 4. So it's exactly same sign and same value. Here it's a negative 1x cubed. This is a positive x cubed. Here it's a negative 4x squared. Here it's the negative 4x squared. Here it's a positive 5x and here it's a negative 5x. So basically this term and this term, there are two similar terms and two non-similar terms. When we say similar terms, they need to have the same number and the same sign. So if all the terms would have been similar, then we say fx is same as f of minus x. This we conclude when all terms are same. And if this is the situation, then we conclude that the function has even symmetry. If fx had all terms with opposite signs when compared to the f of minus x, that is when all terms have opposite signs, then we conclude that the function has odd symmetry. And if we notice that fx has no relationship with f of negative x, then it is a neither symmetry. Now in this case, two terms are matching, two terms are not matching. So we neither have this condition nor we have this condition. Therefore our final answer it's neither of even or odd symmetry. And this is how we conclude if the given function has odd or even symmetry. Let's say we have to find out the symmetry of this function. We solve for f of minus x. So wherever we see x, we sub in minus x. Minus x to the power 4 is nothing but x to the power 4. Minus x squared is nothing but x squared. This is minus 6. So we're ultimately left with 0.5x to the power 4 plus 2x squared minus 6. Now when we compare all the terms of both of these functions, we have 0.5x to the power 4, 0.5x to the power 4. These two are exactly same terms. Plus 2x squared exactly same terms. Minus 6 exactly same terms. So we can conclude f of x is exactly same as f of negative x. And when f of x is exactly same as f of negative x, it's called an even function. Therefore, this function is going to be concluded to have even symmetry. And this is how we determine odd and even symmetry when we're given a function in the form of equation.